Hello everyone and welcome to this presentation. I am Yusuf Al-Gasus and we will discuss about the big data architecture for network security. This presentation explores innovative approaches to safeguarding massive data sets in network environments. So it will explain how we safeguarding and how we save the data within the network. So, understanding the big data. So, the big data encompasses vast quantities of information from diverse sources like social media, digital platforms, and sensors. The main characteristics are defined by the V's, which are five. So they are. It's known as the five V's. Number one is the volume, which is the massive scale of data generated and stored. Number two, the variety, which is the different forms of data from structured to unstructured. And we have number three, the velocity, which is the high speed of data generation and processing. The fourth is the veracity, which is the accuracy and trustworthiness of the data. And the last one is the value, which is the usefulness and insights extracted from the data. The traditional data processing struggles with these complex, large data sets, especially in ensuring security without impacting network performance. So, what are the current technologies used? This section examines the technologies and mechanisms currently used to manage and secure big data. Standard encryption methods such as RSA and AES are commonly applied to protect data confidentially. However, the implementation of these computationally intensive encryption protocols frequently leads to a significant degradation in network system performance, creating a critical bottleneck. Big data sources are categorized into three criteria. First one is the structured, like web and social media. The second one is the semi-structured, such as machine logs. And the last one is the unstructured, like the sensing and graph-based data formats. The proposed architecture enhancing security and performance. So to overcome the existing performance issues, the research suggests the following: data compression, which is like reducing data size first, then the data splitting, which is the dividing compressed data into smaller chunks. The third one is the multi-row transfer, which is the transmitting chunks, which is the transmitting of chunks via multiple network paths. And we have the last one is the encryption, which is the encrypt individual chunks for robust security. So this method ensures that even if a cyber attacker intercepts one data stream, they only acquire incomplete and meaningless information, drastically reducing the risk of a successful breach. So it is helpless for them. So, and then we have the working process, the secure and efficiency, and the efficient transmission, the efficiency of the transmission. So the core working process of the proposed technique involves critical stages, which are the following. We have the data collection, which is gathering diverse big data inputs from various sources. And we have the pre-processing and compression, which is the reducing data volume and splitting into manageable encrypted chunks. And number 3, we have distributed transmission, which is sending encrypted chunks across multiple separate network routes. The last one is secure storage, which is basically storing the fragmented encrypted data in distributed file systems. The traditional approaches often create bottlenecks by applying security layers directly to raw data. The method prioritizes maintaining performance levels required for real-time big data transmission. And here we have the comparison between the traditional encryption and the proposed architecture. In the traditional encryption, we have this. It encrypts full uncompressed data bulk, but while in proposed architecture, it compresses and splits data before encryption. And here we have, which is the traditional encryption, it has high computational overhead. And in the proposed architecture, we have reduced data size, minimizes processing load. Here we have it has like increased latency and slower transmission. Here, enhanced reliability and faster performance. In the traditional one, it has single point of failure for data interception. And in the proposed architecture, it has fragmented data across multiple routes, prevents full data compromise. And the conclusion of the research, the study concludes that the proposed architecture successfully improves the security of big data in network environments. This is achieved by preventing unauthorized access to complete information while maintaining efficient transmission speeds through the utilization of compression and splitting. So the key achievement here is improved big data security and performance through a novel compression and splitting architecture. The future scope is that further research could focus on optimizing compression algorithms for specific data types and applying the architecture to emerging big data sources. And these are the references of the research. And here we come to the end of this presentation. I hope that you benefit from this presentation and it was joyful for you. And thanks for watching and see you in another presentations.